So far we've been dealing with single pieces of information pretty much. You know, what is one person's height? What is one person's BMI? You know, what is one person's pay rate? That kind of stuff. Sometimes, the only time that we haven't been, well, I'll get there. Sometimes you want to hold a series of pieces of data. You want to hold everybody's height, everybody's pay rates, whatever. You want to hold an entire set of exam scores so that you can go through them quickly and add them all up. So that is what you use arrays for. An array is a series of contiguous spaces that holds values. Contiguous meaning that it's all in a row in memory. There are other data structures that are not all necessarily in a row, but arrays are. It's like a series of boxes, you know, mailboxes at an apartment complex. You know, here is mailbox 0, here's mailbox 1, here's mailbox 2, here's mailbox 3. So arrays are variables that can store multiple values of the same type. They are stored in adjacent memory locations. Why is that important? It just means that it can rip through it really quickly. And yeah, that's enough to say about that. They are declared using square brackets. Square braces. I never know whether to call them braces or brackets, whatever. The square parentheses. The next to the P key, you know, those two. So this declares an array of 5 ints. So if we have 5 test scores, we declare an array of 5 ints. Inside memory, like say this is at memory address 1000. And say that an int is 4 bytes long, which it is. This first element is stored at address 1000. This next one is at 1004, 1008, 1016, 1020. That's not super duper important to us, but the idea, I kind of like for you to think, you know, like computers, like computer scientists, how this is working behind the scenes. All we really need to know is how to pull it out. And the way you pull it out is using the square braces. You could say, I want test number 0. So test square brace 0. Or I want the last one. Well, if we start counting at 0, then we can't access element number 5. What do I mean by that? 0, 1, 2, 3, 4. So the last element in the array, consider it as being n minus 1, where n is the length of the array, because it's 0 based rather than 1. That's why I call it homework assignment 0, just to get you thinking in terms that computers like counting in zeros, or not that they do, but that since this array starts at 1000, that's how it calculates where element 0 is. It's 0 times 4, because that's the length, that's the size of it, plus the starting. So that's 1000. And then if you try to get to test number 1, that's 1 times 4, which is the length of an int, plus 1000, and so on. So the array terminology, that's the data type, that's the name, this is the size declarator. I'm usually just going to call it size. But this book says that the size of the array is the number of elements times the size of each element. So I should say that this is the length of the array. I will mess up and I will call it size. That's because other textbooks for other languages use the size word a lot. But this right here has a length of 5. And if we cared about the size of it, it would be 5 times 4, because each int takes 4 bytes. We didn't go over the exam, did we? Shall we? Yeah, let's pause this. May as well go ahead and launch it. So to access array elements, access them, you use the variable name, but then you put square braces and you specify the index number. The index number is which mailbox it's in, which position it's in. And this is going to seem like review because y'all watched the video. So you can go from element 0 all the way out to n-1, where n-1 is the length of the array, the number of elements in the array. You want the first one, you do that. That's equal to that first box. Whatever number is stored here, 123 or 213, that would display 213. Now we're doing a CIN and we're going to store it into that box. So we type in 456. Well, let's go here. That's element 0, so that's element 1. That would get the 456. You must access them individually. You can't just do cout and have it magically print the entire array. So you have to say cout, tests, and then specify which one. This would be like reading everybody's mail in everybody's mailbox all at once. You can't do it. You can only open one mailbox at a time. I'm going to skip that. We're going to do our own assignment like that. So the value that you access the array with, it can be a number or it can be a variable. A literal. Remember, we've been calling those things literals. It can be a numeric literal. It can just be a 3 or a 1 or a 0, or it can be a variable. So let's go play with arrays. New project. Those of y'all who are using like 2015 rather than 2013 or anything like that, are you finding it to be a lot different than what we use in class, or a little bit, or hardly any?
About the same.
About the same. Alrighty. Alrighty, I'm going to add a new file, add new item. # include IOStream. Using namespace std int main parentheses system pause, just all the usual boilerplate, return 0. All right, let's make an array of 5 ints. I'm going to call it scores, like test scores. So int, that's the type, and then scores, just like we've done in the past, a variable name, but then you use the square braces to indicate that it's not just one score, it's a set of scores. It's an array of scores. But you put a number there. I almost slipped into Java syntax there for a while. Okay. That makes space for 5 scores. Now just for fun, let's print those scores out with a loop. Have we done for loops yet in this class? I think I was in a hurry to get to arrays, so I skipped the idea of for loops. So anyways, just do this. Cout scores at element 0, ENDL, and then do the same thing for scores element 1. What we are going to see is that they're not equal to 0. You might think, well, I just created a brand fresh new array. It ought to be full of zeros. Well, in some languages that's true. In this language, it is not true. When it allocates an array, it does not go and zero it out. So you have no real guarantee of what data is going to be in there unless you zero those values out yourself. So until you assign data into that array, it's like when you move into an apartment, until you actually open the door and put some stuff in there, you have no idea what the prior owner of that memory of that apartment stored there. I never know if these similes make any sense or not. So anyways, that's why I printed those goofy numbers. It's because it went out and it grabbed some memory on your computer, but that memory already had data. Why? Now, honestly, every time we run it, you probably all got the same values, right? That -85, whatever. Is that sure? That's because this was compiled in what's known as debug mode. And in debug mode, the compiler goes and adds a whole bunch of stuff to try to look for problems. One of which is that uninitialized arrays are filled with special values that could be looked for. If we did not compile it in debug mode, if we switched it to being compiled in release mode, then it strips a lot of that helpful stuff out, which is a good thing in a lot of cases. You don't necessarily want to ship your customer something written and compiled with the debug mode on. If you're writing code that you don't want somebody else to be able to disassemble and look at and peek at and figure out how it works, you certainly don't want to include the debug information in it. So anyways, let's put some data into this thing. I'm going to delete those 2 lines of code. We have used while loops, though. Is that correct? Mm-hmm. Okay. So I'm going to use a counter. I think I'll just call it C. I'm going to set it equal to 0. And then I'm going to do while C is less than 5. Ask for a value and then let them store it. So C out, enter test score, followed by arrow, arrow, followed by that number C, followed by ENDL. I've goofed. It wants that to be a string. All right, I'm not thinking clearly. How do I convert that to a string?
L on end line.
Pardon me?
You're going to put the L on end line. That might be what's breaking.
Oh, is that what it's really breaking it? Yeah. Okay, thanks. All right, now let's let them enter a value. I could let them store it directly in the array like this, or I could declare a temporary value, read it in, and then store it in the array. I'm going to just do it directly into it this time. Scores at position C. All right, now it's done. Now let's write another for loop that will print those values out. It's going to be another while loop. I need to reset my counter back to 0. So C is equal to 0. Again, while C is less than 5. Why less than 5? Because if the length of the array is 5, then what's the position of the first one? What's its index? What did we say always is the index of the first element of an array?
0.
0. And so we can only go 0, 1, 2, 3, 4. That's why we're making it less than 5 rather than less than or equal 5. So let's see out the number C, or yeah, our counter followed by a tab, followed by the score at that position. Scores at position C. I see a hand, just a second. And then ENDL. Yes, you're right. I have an infinite loop there if you've already run it.
Says, like, you need an increment.
Yeah, there's a problem with this code. And if you didn't hear what Hyde and he said, what's wrong with this? It's just going to go forever because we never increase C. So just tack on C++ right here. That's actually where it gets its name. Okay, here we go. Add this. And then our second while loop is going to need the same thing. You will see a lot of C++ programmers who go and put the plus like right there, rather than do it on a separate line. And that works, but I think that's a little too clever by half.
Should the second one, you have the bracket wrong, don't you? It's in the wrong way?
I have the arrows going the wrong way?
Because they're both facing the same way. No, I meant like on your while. I thought we were doing less than 5.
We are doing less than 5. So while C is less than 5, that's actually good. Unless I'm not seeing it right. I'm going to run it and see.
0 and then increments up every single time.
My mind just kind of went dead. So, yeah, we're back on track now.
Okay, so enter test score 0, 100, 90, 40, 80, 100, and then it prints them out. 100, 90, 40, 80, 100. So you see what we've done. We have an entire set of data, not just one test score. Or, we could put payroll information, or, calculate average wage, or, whatever we wanted to do. And as a matter of fact, that'll be the next thing that we do, is calculate the average. But there's a few changes that we ought to do to make this code a little bit better. What if I wanted 10 test scores rather than 5? What am I going to have to do to this code?
Well, you just increase the while loop's parameters.
Yeah, I could change that to a 10. I could change this one to a 10. But now I've actually broken the code. And you probably know, but I'm going to demonstrate it to everybody.
Oh, okay.
So test score 0, 100, 90, 80, 70, 60. What's the problem? The array was allocated for 5 spots. It only had those 5 memory spaces, those 5 mailboxes. Now we're going to go and we're going to assign something into the 6th one. There is no 6th one. Believe it or not, it's letting me do this. It's letting me write to memory that I shouldn't. I could crash the program by doing this. Bizarrely, it actually worked. But you never are guaranteed. Once you start writing past the end of the array, you don't know what you're writing into. You could be modifying code that controls how your program works. You could be changing other variables that you don't need to be changing. I wanted to see it crash, and I'm disappointed it didn't. Okay, when I hit enter, it at least pops up an error message. Runtime check failure 2. The debugger, the debugging code that I mentioned, checks for this. The stack around the variable scores was corrupted. That means that I wrote too much data to that array. I went out of bounds. So I need to change this declaration to a 10 as well. And then we start seeing, well, maybe I should just declare that as a variable so that I don't have to keep typing 10 every time. And then if I decide that I really wanted 20 scores, I have to go and change it everywhere in my program. So when you declare an array, the best thing to do is to declare a constant before it and then put the size of that in there. So I'm going to go ahead and do that. Constant int size, except I'm going to put it in caps or num scores or something like that. I'm just going to go with size. No, I'm not. I'm going to call it length because the book was using size for a different thing. Is equal to 10. And then everywhere I had 10 or 5, I'm going to put the word length. To save time, I'm cutting and pasting. Now if I want only 3 test scores, I just change that number in one place rather than everywhere. There is something, and it's kind of a trick, but it's not really a trick, that you can do if you have a loop and you don't know the length. You can query the array using the size of keyword to get the length, the size of the array, and then divide that by the size of the data type, and that should tell you how many elements are in it. I will show you what that looks like. I'm going to come down here and calculate the number of elements. I'm just going to call it n. Is equal to the size of the array, size of scores, divided by the size of an int. And then I'm going to print that out. And it ought to say 10 or 20 or whatever. Cout num equals whatever, you know. And I'm going to change that length to 3 so I don't have to enter so many pieces of data. So I scrolled back up and I changed that to a 3. I'm going to run it now. enter test score 0, 10, 20, 30. And it says num is equal to 3. So that actually worked. It did print out. It did calculate the number of elements in the array. So the book says, yeah, that's a great way to code this stuff. Because we could have put this thing, we could have calculated num and put that less than num, c less than num, or we could have done c less than size of scores divided by size of int. But that's not a great way to do it, because the code does not always know the size of the array. If you pass this array into a function or method of a class, it doesn't know how much memory it takes up, so it can't accurately calculate this. So you wind up, in this language in particular, passing in the size of the array into functions that manipulate arrays. So you may as well just define a constant and then just use that one. Yeah, the book tells you that you can do this, and it's true, you can calculate the number of elements, but that's available to you only if you're within the same scope that it was allocated to begin with. If you pass this array into a function to do something with it, it's not going to work. All right. What kind of code would we need that would calculate the sum of this? I'm going to give you a hint. I'm just going to copy these lines, the ones that printed it, and then I need to wander around and make sure that everybody has it working. You know, I don't want to go too far with it, with people having syntax errors. I'll type it in again. But think about it. How would we calculate the sum of the array? What do we need? We need a variable, right? That'll hold the sum. And what are we going to initialize that variable to before anything has been added to it? So I'm going to do something like int sum, but I need to set it to a starting value. What would be a good starting value? I'm just going to go with 0. And then we need to write our while loop again. C is equal to 0 while c is less than length. Sum equals sum plus c plus the array value, or just sum plus equals, whichever way you like to write it. Sum plus equals scores at index value c. And then by the time we get here, we will know the sum. I've got an error. Oh, ENDL there. What am I doing? So I changed that. C out, arrow, arrow, sum equals, end quote, arrow, arrow, the sum variable followed by an ENDL.
You need to have an increment on that.
I'm not thinking clearly. There we go. That's why I like for loops. The increments are built into them. We'll talk about for loops soon. All right, so since I set my length equal to 3, it's only going to ask me for 3 test scores. 100, 90, 80. It says the sum is 270. That's correct. How would I calculate the average now? Divided by length. Yeah. Except I'm going to make that a double. And as a matter of fact, I really should have made sum a double. I'm going to go back up here and change sum to be a double. Why? Because we want to see the whole, the precise average, not just, you know, round it off to the nearest integer. So then double average is equal to sum divided by length, and I'm going to print that out as well. Inner test scores 100, 90, 80. The sum was 270 and the average was 90. All right.